Hello, Accelerated Math 7-8 students. We are working on Module 13, and this is Lesson 4, and it is called Scientific Notation and Standard Notation. Scientific Notation and Standard Notation. Our goal for today is, we will learn how to write numbers and standard notation and scientific notation. The question that I want you to be thinking about is, what must be present for a number to be written in scientific notation? All right, some things to know. Let's move this up so that you can see. All right, things to know. What is the closest power of 10 to the following numbers? Okay, and so we're looking at the number 17, the number 120, the number 999, the number 10,001, and the number 89,997. The question that I'm asking you is, what is the closest power of 10? And when we're talking about powers of 10, I know that you learned about powers of 10 clear back in 4th and 3rd grade, but powers of 10 mean, if you're looking on a place value chart and you have the tens place, the hundreds place, the thousands place, the 10,000s place, the 100,000s place, those would be powers of 10. So if the number is 17, then the question that I want you to answer is, what is the closest power of 10 to 17? So in order to answer that, you would say, for 17, the closest power of 10 would be 10 to the first power. Okay? The second one would be 10 to the second power, because the closest power of 10 to 120 is 100. The closest power of 10 to 17 is 10, and 10 to the first power is 10, 10 to the second power is 100. So then, if we're looking at 999, we would say the closest power of 10 to that number would be 10 to the third power, because that's 1,000. The next one that we know would be 10 to the fourth power, because that's 10,000. And then the last one that we know is 10 to the fifth power, because that's 100,000. And 89,997 is very close to 100,000. So the closest power of 10s, as you can see, would be those numbers. Okay? All right. Is there, or is it more precise to say that you have 10 to the second power dollars or $92? Okay, is it more precise to say 10 to the second power dollars or $92? And the answer to that question would say, I would say it's more precise to say $92, because if something costs $92 and you have exactly $92, then you could pay for it. If you have $100, which is 10 to the second power, it is possible to pay for that, but there's a lot of difference between $92 and $100. So more precision would be the $92. Having a ballpark mind frame of, okay, it's $92, that's really close to 100, then I know I have to have at least 100. So it wouldn't be as precise, but it would give you a clearer picture of what you need. So basically, the reason why I'm asking you all of these hypothetical questions is you have to decide, when is it more important to be exactly precise, which we know as standard notation, versus having a ballpark figure or be thinking about an amount that would work, which could be scientific notation. There is a time to approximate and a time to be exact. And a lot of times when you're thinking about that, if you're buying something, you have to be exact. But if you're trying to figure out the approximate number of kids who attended the dance, then you could do approximating, which would involve scientific notation. All right, just as a quick review on this, standard notation requires you to write numbers exactly. So for example, if we have 224, that's in word form. 224 is in standard form. Okay? Scientific notation is a way to write very large numbers and very small numbers. So if we have 224 in standard form, the way you would write it in scientific notation is it would be 2 and 24 hundredths times 10 to the second power. Now some of you are going, okay, I don't understand scientific notation. Well, scientific notation basically is in the form where you're multiplying any value by a power of 10. So this number right here is 200. So we have to think of the power of 10 that gives us hundreds. And so 10 to the second power gives us hundreds. And then if you multiply 100 times 2.24, it will give you 224. Okay? There are rules that one must follow when writing a number in scientific notation. Okay? First thing that you need to know about scientific notation is it must have one leading digit. Leading digit means there has to be one digit that is followed by the decimal point. Only one. You can only have one digit and then the decimal point has to come next. So that's called a leading digit. It must be a product involving the leading digit and a power of 10. So you have to have that decimal and then it has to be multiplied by a power of 10 in order to be in scientific notation. Okay? The leading digit must be greater than 0 but less than 10. Okay, so it has to be bigger than 0. So this number right here that we're talking about has to be bigger than 0. So it can't be a 0, but it has to be smaller than 10 because 10 would mean 2 leading digits, and we don't want 2 leading digits. We only want 1. And so the only numbers that qualify for that are 1, 2, 3, 4, 5, 6, 7, 8, and 9. Those are the only ones that qualify because it has to be greater than 0 but less than 10. Okay? So a leading digit could be 1, 2, 3, 4, 5, 6, 7, 8, 9, or 10. All numbers following the leading digit must be written after the decimal point unless it's a 0. So, for example, if you see in this number right here, this is a 2 and a 4, which are true values. So you can't just leave them off. You have to include them. But if this had been 2 decimal point 0, 0, 0, 0, then you could just write 2 decimal point 0 because it won't change the value. But if it has a numerical value, which 2 and 4 both have numerical values, you must include them. Okay. Another example of this is if we had the number 3, 2, 7, 8, 4, and we want to change that into scientific notation, then we have to say, okay, 3 would be the leading digit, and then we put our decimal point, and then we have to write 2, 7, 8, 4. But the question is, how many decimal places did we move it? So we go 10, 100, 1,000, 10,000. So then we'd have to multiply it by 10 to the 4th power because we moved the decimal place 4 places, which means that we are actually multiplying it by 10,000 to get this number over here. And so as you can see, these are all valuable digits that don't equal 0, so we have to include them in the answer. Whereas if you have the number 11,000, in order to write that in scientific notation, then your leading digit would be a 1, right? And then you would have 1 because it's a real digit, but I don't need all the zeros because the zeros hold no actual numerical value. They're just placeholders. And so then I would say times 10 to the 4th power again because I have 10, 100, 1,000, 10,000. And so I have to multiply it by 10,000 to get it to where it's supposed to be. Okay? So that's the difference between this last sentence. All numbers following the leading digit will be written after the decimal point. So these have actual numerical value. These do not. They're just placeholders. So you can see the difference between having to have the numbers after the decimal point versus just the number that is a real value after the decimal point. Okay? All right. So now it's practice time because our goal today we will learn how to write numbers in standard notation and scientific notation. So I have some practice problems for you. Okay, so it says, practice time. Look at the following table and write the number that is missing from the box. The standard form should match the scientific notation. Okay, so let's look at the table and see what we've got. So here's our table right here. And so the first number has been done for you. So we can read this number, 1,327,000. And so to turn that into scientific notation, following the rules on the other page, you take the leading digit. Remember, it can only be 1, and it has to be the digits 1 through 9. So 1 would be our leading digit, so we write that. And then we put a decimal point following the leading digit always. And then if it has a numerical value and is not just a placeholder, then you have to list it. So we have 1.327 times 10. This is where you have to count to see how much of the power of 10 that you have to multiply it by. So you do that by counting the placeholders. So we have 10, 100, 1,000, 10,000, 100,000, 1 million. So we have to take this number right here and we have to multiply it by 1 million. Now, I want to show you something on the calculator. It's really cool that tells you if you did it correctly. So, take out our calculator, and it has to be this kind of calculator because you have to be able to plug in exponents. So, our number again was 1.327, and then I'm taking it times 10 to the power of 6, and what do we get? 1,327,000. Does this number that you see on the calculator mirror this number over here in the box? And as you can see, it does. So do you see how cool that is? You can use a calculator to help you. All right, so let's try the next one, see if you can get it. So the number is 54,000. So what would your leading digit be? If you said 5, you are correct. So you're going to put 5, decimal point, and then 4 has a true numerical value, so we have to include it. Do the zeros. No, they're just placeholders, so we don't have to list those. Times 10 to the, and we have to figure out the power. So let's count by 10, or by place values. So 10, 100, 1,000, 10,000. So it would be 10 to the 4th power. Okay, because 10 to the 4th power is 10,000. All right. So your job for the rest of this to do on your own is to fill in the blanks that are missing. Oh, let's look at when you have negative exponents, because we're learning a lot about negative exponents, especially in the last lesson. You go the other way. So you find your leading digit, which your leading digit has to be 7 because it's in between 1 and 9, so they wrote 7, and then decimal point and any other digits to hold real value, which 6 and 4 do. So we're listing those. We do not have to list the zeros before, times, but here's what you got to think about. It's times 10 to the negative 5th power, which would be 10, it would be 1/10 times 1/10, 1 times 1/10, 1 times, okay, so I have to write it because I'm stuttering my words. Let's see. Okay, so if we take 7.64 times 1/10 times 1/10 times 1/10 times 1/10 times 1/10. Remember, I have to do it 5 times because when you have a negative exponent, that tells you how many times, and then my base has to be that number. So I know 7.64 times 1 times 1 times 1 times 1 times 1 still gives me 7.64, and then I know that 10 times 10 is 100, times 10 is 1,000, times 10 is 10,000, times 10 is 100,000. So then I have divided by 100,000, and let's see what we get. So here's our calculator for proving this problem. 7.64, 7.64 divided by 100,000, make sure we've got it, yep, okay, equals, and now look, does this number that you see on my calculator, move it over here so you can compare them, does this number on my calculator mirror this number in the box? And as you can see, it does. All right? So we just proved that this showing our work in expanded form is what is happening right here. So we have 7.64 times 10 to the negative 5th power. This is what you're actually doing. Okay? So here's something to keep in mind. If the number is a whole number, then your exponents are going to be positive. If your number is less than 1, then your exponents are going to be negative. So that'll give you a hint how to find this one, and that'll give you a hint how to find this one. Okay, so that's your challenge, is to figure those out. All right, kiddos, let's revisit our goal. And our goal for today was, today we will learn how to write numbers in standard notation and scientific notation, which we just did. What must be present for all numbers to be written in scientific notation? 2 things. First thing is you have to have a decimal point with only one leading digit prior to it, and the leading digits have to be 1 through 9. And then the other thing is that you have to multiply it by a power of 10. Okay? And you're going to fill in that box for me. All right, that's all I have for you. Have a good one. See you later. Bye.